All right, so let's do the last chapter the last section, of chapter 8. It's called Angles and Circles. Well, we've already talked about a lot of angles and circles up to this point, but we're just going to do some more. So they could probably call it more angles and circles, all right, because we've already done a lot of that. Let's do this. Do you remember, let's review just briefly, because this one has a little bit to do with, oops, let's hit the shift key. There we go. All right, here's a circle. And we had a relationship between this inscribed angle and its arc. Do you remember that? What's the last thing we did, I believe?
Oh, yeah, it's 2 times the arc.
Okay, it's 2 times the arc? The arc is 2 times the what? The angle. And what do we call that angle right there? Inscribed angle. Why is this an inscribed angle? It's on the circle, the vertex. Okay, the vertex is on the circle. Very good. So we're getting some of the weekend cobwebs out of our head here. All right, so the vertex is on the circle. It cuts off, that's how we say it. It cuts off an arc, right, from there to there. I'm not going to draw it, but from there to there is our arc. That arc is twice as big as that angle. Everybody with me on that? Okay. So we've actually, Zach, you brought it up earlier, the word tangent. All right, so here's a situation where I have a tangent and it hits right here. What do I call that point where the tangent hits? Anybody remember that? Point of tangency. It's the point of tangency, all right? And I could draw any, let's see, what do they say? It says the measure of an angle formed by a tangent and a secant. Okay, so what I'm going to do, I'm just going to take the secant from that point. I'm not going to go all the way through. Okay, a secant could just go from one point to the other like this, and that's what I'm going to do. Okay, one point on the circle to another point on a circle. Technically, the secant is a line, so really, technically, if it's a line, that thing should be doing what? Just keep going forever, right? But I just stopped it here, and I just stopped it here, just to make it a little easier for us, okay? Now, that thing, I'll tell you what, I made it look too much like a right angle. Let's not make it look like a right angle. I'm just doing that just so it doesn't look like a right angle, because really, what we're going to say right here has nothing to do with, being right angles, okay? It forms an angle. Between this secant and this tangent, you have an angle that's formed, okay? Let's go different color. Say that again. Pink? All right, we'll do the next one in pink. We'll do this one in yellow, since I already picked it. See that angle right there? So I went a little bit beyond it. That's close enough. Okay, that angle right there, okay, that's not an inscribed angle though, is it? Now, the vertex is on the circle, that's true, but this is not a chord, right? This doesn't even go inside the circle at all, does it? Okay, so it's not really an inscribed angle, but it is an angle. They don't have any fancy word for it. They just say this. It's an angle formed by a tangent and a what? What did we say this was? A secant. So when you have an angle formed by a tangent and a secant, this relationship is true. It cuts off an arc though, doesn't it? Where does it cut off? It starts here, right? And then that arc goes all the way to there. Now there's a relationship, and it's a relationship that we just talked about with the inscribed angle. So technically it's not an inscribed angle, but the math works out as if it was an inscribed angle, all right? So this angle, what do you think? With all those hints, this angle is how much of that arc? It's half, exactly right, all right? It works the same way as an inscribed angle, but it's not an inscribed angle. It's an angle formed by a secant and a tangent. Everybody got it? Okay, so again, there's no fancy name for it, but we just say that this is an angle, this skinny little yellow angle right there is an angle formed by a secant and a tangent on a circle, all right? So that angle is half the arc. So if that arc is, I don't know, make it easy, 100 degrees, what's the angle then? It's 50 degrees. Simple. No big deal. Everybody got it? So that's our first theorem. I didn't write the theorem down. It's in the book if you want to write it down. But to me, writing it down and seeing all the words sometimes gets real confusing. But if you see the picture and you see the relationship between those things in a picture, then That's how I learn better. I don't know about you. Do you? Would you rather see the picture? Yeah, I would. All right. All right, here we go. This one's a little different. It's the same idea. All right, this is the example. That was just basically talking about the theorem. This one is an example, and it's a little bit tougher. Okay, they don't just tell you the angle and you got to figure out the arc, or they don't tell you the arc and you got to figure out the angle. All right, you got to do a little extra. It's not that much extra, but it's a little bit. So let's see what we got here. We got a tangent. So again, technically a tangent keeps on going forever and ever, but so you should put arrows on the ends, but I am not going to. Just because I'm lazy. And then there's a secant. Same thing. A secant is a line. So a line technically goes on forever and ever, but I'm just starting it and stopping it, okay, at that point of tangency and at the point on the circle. Everybody okay with that? And they tell you that this arc right here is 240 degrees. Let's put some letters. X, Y, Z. And this is W where it hits right there. And that's it. Okay, we don't even care about the center of this, so I'm not going to put that in there. So what you want to find is angle. So they ask you to find angle WYX. All right, so let's figure out which one that is. Let's do it in a different color. We'll go pink, since Simone likes the pink. WYX. So we're trying to find that angle right there. Well, we just learned something. What did we learn? We got a secant and a tangent. The angle that's formed, right, between that secant and the tangent cuts off an arc, doesn't it? It cuts off this arc from there to there. Did they tell me what that arc is equal to? If they did, then that angle would be easy. I'd just take half of that number, right? But they didn't tell me that arc. But we can figure out that arc. That's really the only thing different. It's really not that much more difficult. What do you think? Exactly right. It's not that hard. Because look, this whole thing from here to here is 240, right? This is just what's left over, right, from the whole circle. So what's our math? Just like Simone said, 360 minus 240. What is that? It's 120. What does that mean? That means this pink one right here is 120 degrees, which means now it's super easy to figure out what that angle is. What's that angle now? 60 degrees. That's it. It's not hard, is it? No. Okay, let's do a couple more. Oops, I'm going to copy that. Everybody good so far? Yeah, that wasn't hard. All right, so now what we're going to do is we are going to draw two secants that intersect each other. Again, technically, these secants, you should put arrows on them because they keep going through, but that's okay. All right, this one's a little different. This is not a central angle, is it? Why is it not a central angle? It's not the center, right? Let's not say middle, let's say center, since it's a circle. Center would be right here. I didn't put it in there, but you know the center would be about right in here. So it does not hit at the center. So this angle is not equal to this arc. Would you agree? Because it's not a central angle. Now, if they did intersect at the center of it, then yeah, they would be equal to each other, okay? But they're not. Now, I do know something, though. I know that this angle is equal to something else. What is that? This one right here. What do we call those? What's the name for it? They're called vertical angles. Good. All right, so we know vertical angles are equal. All right, so we know those are equal to each other. But there is a relationship, and let's put some letters in here. This is A, E, that's B. This is C down here, and this is D right here. Okay? And let's do this. Let's say that's angle 1, just to make it kind of easy for us. Okay? So I'm going to write down, I'm not going to read it off to you, but I'm going to write down what this theorem says. Everybody ready? Let's scoot it over just so I have some room to write. All right, so angle 1. I'm not going to like try to prove it to you or anything else. I'm just going to show you. This angle, I will read it off to you, kind of like in my head. This angle right here, it could be this one or it could be this one. Why could it be either one? Because they're the same, right? So either one of these, angle 1, we'll use this one. It's not equal to this arc and it's not equal to this arc, but it's equal to the average of those two arcs. Okay, so how do I find the average of those two arcs? Well, I take the arcs and I do what to them? Add them up. So I got arc AB. What's my other arc? DC, right? Or CD, doesn't matter. But then I do what to it? Remember, it's the average divided by 2. Exactly right. So you could, if you wanted to, you could put divided by 2 like that. I think the book puts, what do you think they do? They put a 1/2 in front of it. All right, but either way you want to do it, it's perfectly fine. All right? Think you can remember that one? So if I take this arc and this arc, add them up, divide them by 2, then I got this angle right here. So that angle, it's not a central angle, but it's an angle formed by what? 2 secants, right? 2 secants that intersect. But I like how you said it. 2 intersecting secants. All right. So if you have that situation, the angle that's formed is equal to the average of those 2 arcs that it cuts off. So you just add them up, divide them by 2. Easy as that. You could, let's just do this. Let's call it angle E. All right, that one right there. What would that be? So we'll just call it angle E. I really shouldn't call it angle E because, well, I could call it angle E. That's fine. So angle E would be what? It'd be half. Well, no, let's just go from, just use our letters right here. What arcs does this angle right here cut off? AD and BC, right? So if I took AD and add it to what? BC, right? See this arc right here and this big one right here? If I add those up and divide it by 2, I could get this angle right here. Everybody with me? All right, so it's saying the same thing. I'm just doing different angles. All right, good enough. Let's do an example. And then I've got basically one more. The one that I have to do has a couple offshoots of it, but so here's another circle. Let's draw. Let's click off of that. Let's draw a secant right there. Let's draw a secant right there. Let's put some stuff in here. So this is an example, so we're actually going to put some real numbers in here. So this is, and it's not drawn to scale, so don't look at it and say, well, that should look like this. Okay, we're just going to put some numbers in. We're going to say that's angle 1. We're going to say that that's 85. And we're going to say that this is 120. And I think that's everything they tell you. Yes. And we want to find angle 1. This is what we're trying to find. That angle right there. All right, well, what do we got? We got 2 secants that intersect inside that circle, right? So what do we just know? We know that the arcs that they cut off, all right, let's see the arcs that they cut off. It would be what? This 85, right? And what? This angle that or this arc that we don't know, right? It's the only one that we don't know. So how could we find it? Yep, exactly right. Add up these 3, take it away from what? 360, okay? So you could go 360 minus what? 120 minus 85 minus 45, and that's going to give you 110. I already did the math, so that's 110. So you could come over here now. Let's do it in yellow since this is stuff that we're figuring out. So we just figured out that that arc is 110. And now it's super easy. That was the only extra step that we had to do with this. Okay, we had to find that arc. So how do I find angle 1 then? Angle 1. Add them up. Right, let's average them. So I'm going to go 85 plus 110 and divide it by 2. I could put the 1/2 in front of it, but I kind of like when I'm actually doing the math, I kind of like to put over 2. I don't know about you. Actually, in my notes, I didn't do that. I put 1/2, but it doesn't make any difference. You stick it in a calculator, I can't figure that out in my head. So that's 97.5 degrees. And that's what that angle is right there. Again, it doesn't look like it. It looks like less than 90, but I just didn't draw it very accurately. But it works out with the numbers, though. Okay, works out. We good? So, what have we done so far? We have, let me write this down. So the first thing that we did was we did a secant and a what? And a tangent. All right, so that's the first thing we did. What's the second thing that we did? I'll write it right here. We did what? Two, okay, yeah, let's say it. Intersecting secants. Everybody good? Oh, you know what? I didn't mess up. I just kind of forgot this a little bit. Notice, these two intersecting secants, where do they intersect each other? Inside what? Inside the circle. That's a key because of the next thing we're going to do. Almost forgot about that. All right? So they intersect inside the circle. Where does a tangent and a secant intersect? On the circle itself. Okay, actually on the circle. All right? But we could draw two secants that actually intersect not inside the circle, but outside the circle. Okay? So that's what we're going to do. I'm going to draw two secants. Let's copy this again. Let's draw a circle with two secants, but these secants are going to intersect outside the circle. And we're going to have a relationship between an angle and an arc, okay? And a couple arcs, actually. So how would I draw that? Well, let's do this. Let's draw one like this. Let's draw another like that. So those are both secants, agreed? But where do they intersect each other? Outside the circle, all right? So this is a little different. They still form an angle, don't they? We'll call it angle 1 since we've been calling this angle 1 all along, so we'll call it again. And this angle right here would be the same thing, wouldn't it? Because they're vertical angles, but we're going to use this one right here. But it also cuts off some arcs. So angle 1 cuts off this arc, and it cuts off this arc right here. Which arc is the bigger arc? The one that's further away from the angle. Everybody see that? So the big arc is always going to be, because if it goes out like this, the further you go out, right, the more distance between the secants. Yes? All right, and the secants get closer, closer, closer until they actually touch each other right here. All right? Now, here's the relationship. Actually, let's do this. Here's the relationship. Angle 1 is equal to, we got to put some letters in here. Let's put some letters. So we'll call that A, B, D, C, and E. All right, that's going to help us a little bit. So angle 1, this is different. It's slightly different. It's close to what we did before, but it's a little bit different. So we're not going to add these two together and then take the average, because look, this is a kind of a smaller angle, isn't it? All right? Because if that point was inside here, that vertical angle would be a little bit bigger. So when it was inside, we added them together and divided them by 2. What do you think we're going to do? I'm giving you huge hints here. We're going to subtract them from each other and then divide them by 2. Okay? Now, in subtraction, does it matter what order you subtract things in? Absolutely. Okay? So we always take the bigger one minus the what? The smaller one. So we can't just add them in any order. Or subtract them in any order. So what's this going to be? This is going to be 1/2 of what? EC or CE, doesn't matter how you write it, minus what? BD, arc BD. So when they intersect outside, when you get two secants and they intersect outside the circle, what's the key thing to remember? This is not average this time, is it? Okay, you're subtracting the two arcs from each other and then taking half of it. Can you remember the difference? So when it's inside, when they intersect inside the circle, you add them, the two arcs, and divide by 2. When they intersect outside the circle, you subtract them and then divide by 2. Two more and we'll be done. I think we're right on. Well, we got an example too. Let me get through this a little quick. Yeah, this is kind of what we talked about earlier. Remember we did a secant and a tangent? We're going to do that again. But on the first secant and tangent, let me scooch here. Let's use this. The first secant and a tangent, where did they hit? They hit right on the circle, okay? But now we're going to do a secant and a tangent that don't hit right on the circle. All right, there's our circle. Here's our secant, and here's our tangent. If I can, I might have to change that secant a little bit. Nah, it's okay. I can do it like that. Have that go out like this. Have this go out like this. Now, I got a secant and a tangent again. And you remember what we did when they intersect on the circle itself? We added... Or, I'm sorry, it was just half of the arc that it cut off. But this one, if it goes outside the circle, there's not just one arc, is there? So what are my arcs? This is kind of weird. It's this one. And I'll change colors. And it's this one. Okay? Everybody see that? Let's put some letters in here. Be a little bit easier. Let's see. This is F. This is E. This is A. It's where they intersect right there. That's the A. Then way down here is, what is that? A G. Not really going to use that, I don't think. And then this is a B right there. I think that's everything. And an angle. Well, again, we'll use the 1 again. All right. So let's write it down. So angle 1 is equal to, what have we been doing the last couple? Half, right? Now, with this, again, it's outside the circle. So what are you going to do with the two arcs? You're going to subtract them. So this is BA minus what? AE. And that's our theorem. So what's the theorem for? The theorem is for a tangent and a secant that intersect where? Outside the circle, okay? The first one, when it was just half of the arc, they intersected right on the circle. So you didn't have to add or subtract anything, right? There was only one arc that was formed. This one, there's two arcs that are formed, this green one and this blue one. So you got to do something with those two arcs, all right? And you subtract them because it's outside the circle. We got one last one to do. What do you think the only thing we haven't talked about yet? It's two secants. I'm sorry. It's two tangents. Thank you. See, I don't mind if you correct me. Well, it's because I'd forgotten, though. Believe me, I forget a lot of stuff. All right, so what we're going to do is two tangents that intersect. We already did two tangents. No, we didn't do two tangents, did we? Did we? Did we? No, we didn't. Yeah, no, but we haven't talked about the angle that's formed by two tangents, though. No, we haven't done that yet, okay? So there's one tangent, and I don't know, here's another tangent. And where do they intersect each other? Outside the circle. Really, that's the only way. Is there any way you're going to get two tangents that intersect inside the circle? No, because that flies in the face of the definition of a tangent, right? Tangents are always outside of a circle. So there's no way they're going to intersect inside the circle. So you could probably guess, and let's put some letters in here. You could probably guess what the formula is for this, or the equation, whatever you want to call it. All right? What do you think? Angle 1's equal to what? Well, what do you think you're going to start off with? What is it? The 1/2, right? Let's do the 1/2. Now, it's outside the circle, so what do you think you're going to do with the arcs? You're going to subtract them, okay? So what are the two arcs that you're going to subtract? CBA. Why'd you go CBA? Why didn't you just say CA? Because there would be two CAs, right? This is the major arc. Remember that? Major and minor arc. Okay, this is the major arc. That's the bigger one, so that's what we have to say. We have to use the three letters. Because if I just said CA, I don't know if I'm talking about this little one or the whole big one, correct? That's why we have to put that other letter in there. That makes sense, doesn't it? Yeah, because it would be really confusing if we didn't do that. So CBA, what? It's outside the circle, so what do you think you're going to do? Minus what? CA, arc CA. Very good. And that's it. So this is two tangents that intersect outside the circle. So it's a lot to remember, but really it's not that much to remember, because if these things, whether they're tangents or secants or one of each, I shouldn't say one of each. If they're secants or tangents, they intersect what? Outside the circle, then you're going to do what to it? You're going to subtract, okay? If they intersect inside the circle, you add. If they intersect on the circle itself, then it's just the angle, okay? You don't add or subtract. You just have one arc, so you should be good with that. Simone?
When you subtract, it doesn't matter which way, since we went CB, it doesn't matter if we go ABC.
Oh, it absolutely matters. Because what if you went smaller minus bigger? Look, what if you went 2 minus 5? Is 2 minus 5 the same as 5 minus 2? No. All right? So you have to go what? The bigger one minus the smaller one. So you have to have that one first when you do subtraction. So because you can't have a negative angle. Well, technically we can. That's another lesson. But for right now, we can't have negative angles. Go ahead, say it again.
I was just saying, can we go ABC minus?
Oh, that doesn't make any difference. No. CBA, ABC, it's the same exact thing. I thought you meant, can you go this arc minus this arc? No, you can't do that. But yeah, I could call this ABC. It doesn't make any difference. I could call this AC instead of CA. That doesn't make any difference. I thought that was kind of understood, so I didn't really talk about that. All right, we good? I got 4 minutes. Let's do an example. Can we do an example in 4 minutes? At least I'll set it up for you. If I don't finish it, then work on it on your own before you do the homework. It's in the book. Let's make it a little bit smaller so I can fit everything in here. All right, check this out. I got a couple tangents. There's one right there, and then there's one right there. Let's extend that out. Let's extend this one so they touch. All right, so there's two tangents, correct? And then we have a secant that also hits right there, like that. Okay? And they tell you that this whole thing is 40 degrees, that between the two tangents. They tell you, let's put some letters in here, W, Y, Z, V. And this is X. All right, and they tell you that this is I don't know why they do that. They put an A right there. I don't know. It just makes it a little easier to do the math on one of the problems, okay? So instead of calling it WY, just call it A. Is that all right? And they tell you that this one right here is 88 degrees. You're writing all this down? And this arc right here is 145 degrees. And they ask you to find 3 different things. I'll just write it down. I don't think we'll have enough time to do them, so I'll let you try this one on your own, okay? And it's in the book. You can look to see what the answers are. So it's find angle Y, X, Z. Then number 2, you're going to find arc WY. And arc WY is A, so basically you're finding A. Let's make my arc look a little nicer. And then the third thing you're finding is arc WV. West Virginia. Okay, so let's mark them, and then I'll let you work on it on your own. So angle, YXZ. Where's YXZ? There's Y, there's X, there's Z. So this one right here. So this is number 1. That's what you're trying to find right there. And then arc WY is this one right here. That's number 2. That's what you're finding. You're finding A, basically. And then WV, arc WV is this one right here. So this would be number 3. So those are the things that you're trying to find. Okay? Everybody good? So do that first before you do your homework, okay? And here is your homework. So it's 8-5, and it's pages 379, 380, and you're doing 16 to 30. Is that what I put in your lesson plans? Just making sure. I'm looking on my notes, not the lesson plans. So there you go, right there. And that's it. Took us right up to the bell. Perfect timing. But get that example done first. Make sure you know how to do that. Then you should be able to do the rest of the problems. Everybody good? All right.